Hi, this is Craig Stocks here at Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And today we're going to be looking at this image of M81. Now there's not much data here, so I'm in the process of capturing more data for an hourly rental client. But I thought I'd go ahead and put together the video showing how to process it with the data that I have available after just being able to capture about an hour's worth on the first night. So stick around and we'll go through how to process this image in PixInsight and Photoshop. So just as a brief review of my workflow, I will start in PixInsight, and that's where we'll do the initial calibration and integration, sometimes called stacking, of the data that I captured. And once we have it stacked, then we'll use PixInsight to do some preliminary processing of that data that will result in a stretched image of the galaxy separated from the stars. So we'll have a stars image and a galaxy image. And we'll also have a third image that was captured with a dual-narrowband filter that we'll use to pull in the hydrogen alpha. And so just looking at the result, this is the result of the M81 galaxy. And these red areas that you see, those are actually hydrogen emission nebulae in M81. And if I turn off the layers that have just that data, you can see that's what it looks like without adding the additional hydrogen from the dual narrowband filter, and that's what it looks like with it. So it adds, if this were a soup, you would say it adds a little bit of seasoning or a little bit of salt to the soup. So it certainly dresses it up a little bit, and that's why we're including that data from the Optolong L-Enhance filter, which is a dual narrowband, meaning that it passes narrowband data only, and it's a dual narrowband, so it's passing two narrowband slots, and one is the red hydrogen alpha and the other is the blue-green of oxygen 3. And there's not much oxygen 3 in here, it's mostly hydrogen. So with that, let's jump into PixInsight, and in order to process the data, we'll start with our batch processing script, which is WBPP, or weighted batch preprocessing. And we have to configure this for the kinds of data that we collected from the telescope. And in this case, we captured color data. And so let's just look at how let's just clear it out and we'll just start from scratch. So I'm going to reset everything, clearing all files and keeping the settings from the last session. So on the top, we have tabs for bias, darks, flats, and lights. And then we have a calibration tab that has some settings, and then a post-calibration tab that has some settings, but mostly we would use it for information. And then the last tab shows the processing pipeline. So let's start with lights, and the thing we need to do is load the light frames that I collected. So in this case, I collected these light frames last night and sent a download link to the customer. So to add the lights, we need to click on one of the plus buttons down at the bottom, and we want to add lights, so I'll click on plus lights. And we'll just go to the folder where I saved the M81. And so here are the light frames. You can see some of them are labeled L-Enhance and some of them are labeled Luminance. And the Luminance was just taken through a clear glass filter with a one-shot color camera. So we'll select all of these and click Open. And so we've loaded 10 Luminance frames and 6 L-Enhance frames. And we also need to load calibration data. And in this case, what I did was send the customer a folder that has calibration masters. So they've already been processed into a single master file instead of having individual flats and darks and bias frames. And so to load that, we'll use the plus directory button, and we'll just navigate to the folder where we saved those calibration masters. So in this case, this is the plane wave CDK 12.5 with a color camera. So I select that folder, and that folder has in it the masters that we're looking for. So select folder, and PixInsight goes through the folder and any subfolders that happen to be there, finds any files that it knows what to do with, and loads those in the appropriate spot. So now if we look at bias, we can see there's now a master bias frame. We have master darks for 600 seconds, 300 seconds, and 120 seconds. And we have flats for the L-enhance and for the luminance filter. So flats are done by filter, darks are done by exposure time. And then bias is just a single setting, and that's with the shortest possible shutter speed, 0 if your camera will support it. So at this point we have all of our bias, darks, flats, and lights loaded. So we can go to the calibration tab, and there's a few settings that we need to adjust here. First, the organization of this tab. You'll notice on the left-hand side it lists the bias, dark, flat, and light frames. In the center there are some settings, and the contents of this column will change depending on what we select over on the left-hand side. So for instance, if I click on the L-enhance of the flats, you can see that we get, among other things, a box that says CFA settings. Now, CFA stands for color filter array, which means it's a camera that has a color filter array or a color camera as opposed to a monochrome camera. And these are from a color camera, so we need to click CFA images to confirm that these are in fact color images. And we have two rows of flats here. We have the L-enhance and the luminance. So I want to apply to all flat frames, which means I want to apply it to both the top row and the bottom row. And yes, confirm that we really do want to do that. So now we have told PixInsight through WBPP that these flats are from a color camera. And now let's come down to the lights, and we need to do the same thing. You'll notice when I click on one of the light rows, the contents of the middle column changed. And again, we need to click on CFA images. And in this case, we need to specify a mosaic pattern of RGGB. And then again, apply to all light frames, because this applies to both the L-enhance and the luminance light frames. I also like to set a output pedestal of 300. So just enter 300 and then apply to all light frames. Now lastly, and this is a little bit unusual, notice that the L-enhance has a warning symbol. We've got a check mark on the luminance, but we've got a warning symbol on the L-enhance. And the problem, if we look at the warnings over here, you can see that the exposure differs from the master darks exposure. So if we go back and look, if you recall in the master darks, I said we have 600 second, 300 second, and 120 seconds. If we look at the lights, you can see that actually the L-enhance are 700 seconds, not 600 seconds. That was a mistake on my part. I inadvertently changed the exposure time from 600 to 700 seconds. Not a problem, 700 seconds works just fine, but we don't have a matching dark. There are two solutions to that. One solution would be, well, there's three solutions. One would be to throw these out and reshoot them at 600 seconds. A second solution would be to go back and create some darks at 700 seconds. But there's a third solution that is easier, and in this case, if we go to the calibration tab and select this row for the L-enhance, notice under calibration settings there's a checkbox for optimize master dark. What an optimized master dark does is it is able to adjust for different exposure times. So if I click on optimize master dark, you'll notice immediately that warning went away, and now we have nothing but green checkboxes, and it's going to use this bias frame to create an optimized master dark so that we can use this 700 second exposure. So all is well with the world now. The last thing we need to do is come down to the bottom right where it says registration reference image. We want that set to auto. We'll let PixInsight choose the best reference image. And lastly, we'll choose a swap folder. And I have a folder on my D drive that's just dedicated to swap files because PixInsight generates a lot of swap files. And we'll choose this M81 folder as the swap folder. And at this point, we're ready to run. So when you click on Run, it will do a quick air check, and it confirms that we have enough space on the hard drive. And the only warning is related to, well, actually the only warning is about the letting us know about the master dark. So at this point, it's ready to run. We just click Continue, and it will go off and do its thing. Now, I've already done that, so I'm not going to run it now. Instead, let's take a quick look at the post-calibration tab, and it tells us that we've got 2 hours of data. We've got 1 hour and 10 minutes of L-enhance and 50 minutes of the luminance. As you'll see, the L-enhance data is not very good. We had some clouds trying to come in that eventually settled in and closed the observatory around midnight or a little after last night. So the L-enhance data is not very good. I'm not actually counting this as part of his data. I'll reshoot it probably tomorrow night, but it's good enough that we can go through the processing. So at this point, we've already run it, and WBPP is done, and it returns back to this screen when it's done. So we just click Exit. And now we need to open our master files. So the first challenge, if you're new to PixInsight and WBPP, is where are the files and what do I load? The easy way to do that, if I just double click somewhere here in the canvas, it will bring up the Open File dialog. And if we navigate to that M81 folder, you can see that there are now 5 new folders that PixInsight created. There's a calibrated, a debayered, a logs, master, and registered. Now the process that WBPP goes through is first it uses those dark and master and bias frames to create a set of calibrated files, and it creates a new copy of each one of the light frames that is calibrated. So if we look inside calibrated, we'll see there's 2 folders, one for luminance, one for L-enhance. And if we look inside luminance, you can see there's copies of all of our original light frames, and it has _C appended to the file name. So these are new copies, and these have been calibrated with those flats and dark and bias frames. The next thing it does is go through and debayer, which means converting a raw file into a color image. And that's in the debayered folder. And again, there's a folder for each one of the filters, one for luminance and one for L-enhance. Next, it chooses a reference frame, and then it registers all of the light frames. So if we look at our luminance again, for instance, in the registered, you can see again we have each one of those files, but now the file name is appended not only with the _C for calibrated, it has _D for debayered and _R for registered. So now these are calibrated and registered image so that the stars all line up in the same place. The last thing it does is the actual integration or stacking, where it takes all of these files and creates an average of all of them. And what averaging does is it averages out the noise. Noise in each one of these frames is basically a random variable. It appears randomly at different places in each image. And so by averaging the files together, that noise gets averaged out and you wind up with a much cleaner image. So let's go back. The last file folder that gets created is the master. And inside master, you'll see that you have 2 master lights. There's a master light for luminance and a master light for L-enhance. These are the 2 results that we want to load from WBPP that created these on our hard drive. And now we'll open these in PixInsight to do our basic preliminary processing. The first thing you'll notice when you open these is that the window just looks black. It looks like there's nothing there. And that's because these images are very dark. The sky's dark, cameras even with long exposures. Most of the information is still down in the very dark end of the spectrum. So in order to see what's there, we need to do what's called stretching, which is basically brightening the data in a nonlinear way so that we're brightening the midtones and the dark tones more than we brighten the highlights. We don't want to if we have something that's already bright like a star, we don't want to take it beyond white, and which is be considered blown out, but we want to brighten the dark tones. Fortunately, PixInsight gives us a tool to do that that's called the Screen Transfer Function, or STF, or Auto Stretch. It's basically a way to preview a file that is real dark like this, to brighten it up just for viewing purposes only. It doesn't actually change the file, it just brightens our view of the file. And I can get to that through this icon, and your toolbar may vary a little bit, but somewhere on the toolbar you'll have these icons, and this one with the little radioactive symbol is the STF Auto Stretch. And when I click on that, it'll apply an auto stretch to this file. And now we can see what it actually looks like if we were to brighten it using this same set of stretching algorithms. And we can go to the luminance, which would be the plain RGB, and do the same thing to get a preview of it. And there it is. Now, the first thing you'll notice is there's a very strong color cast, and that's completely normal with these images. Most of the time, one of the colors is going to be dominant. Sometimes they're green, sometimes they're blue, sometimes they're red. In this case, it's kind of an orange color. There's two ways that we could fix that. One is if we actually open the STF dialog, which we can get to through Process. All Processes is probably the easiest way to find it. And there we go. It's listed as Screen Transfer Function. So this is what the dialog box looks like that controls the settings of this auto stretch. And again, you can see if I click on the radioactive button here, it will calculate the auto stretch. But notice that there's a link here. And what this is doing is telling it to link the RGB channels so that it's stretching all three of them the same amount. And when you do that, if there's a little bit of a color cast, you can really accentuate that color cast. So one thing you can do is unlink the files and then recalculate the screen stretch or auto stretch. And you'll notice now what it's done is it's stretched each channel so that we get a uniform result. And now we get a nicely colored result. The problem is we don't know if it's the right colors. It certainly looks better, but we don't know if it's the right colors. And we want to try to get the right colors rather than just good colors. So this is a way to see what it looks like, but I would recommend that you leave this linked, and instead we're going to use a different set of tools to clean up this color cast. We're going to start by using a tool, and this is a third-party tool that you can install called Graxpert, and it is a gradient removal tool. Most images are going to have some gradient in them, some more than others depending on your sky conditions. But it also does a preliminary job of removing a color cast. And so we'll just grab, when you download and install Graxpert, it actually downloads the program, and then you need to download a second tool, which is the toolkit that goes in PixInsight, and it winds up under Tools, Toolbox, Graxpert. And what this does, Graxpert's actually a separate program, but this gives you a tool that you can run Graxpert on one of these images without actually having to save it, go open a separate program, run the program, save the result, load it back into PixInsight. It does all that for you behind the scenes. So we can just drag the triangle from this Graxpert dialog box onto the image that we want to process. And apparently it wants us to use the checkbox, so we will use the checkbox to execute this. That's one of the challenges with PixInsight. The user interface is is the worst thing about PixInsight. It has kind of its own way of doing things that doesn't necessarily match the typical way other programs work. And it's something that after you use it for a while and build up a little muscle memory, you just kind of get used to it. But you can see now that Graxpert has run on this image. If I update the screen stretch, it looks much better. Still a little bit reddish, but it looks much better. Now let's do the same thing on the dual narrowband data. And we're going to do something different with this one. We're going to apply a saved icon. So what I did, if you open the, go back to Tools, Graxpert, if I grab this triangle, and this is true pretty much uniformly across PixInsight, if I drag out this triangle, it will create a new instance of that process, which is this little process icon right here. And if I close the dialog box, you can see that this process icon is still there, and it retains whatever settings I had in that dialog box. I can rename this just by right-clicking and choosing Set Icon Identifier, give it a different name, and then drag it over here, and at some point save a blank project that has all of these process icons saved. And then that way, the next time I want to run Graxpert, I can just grab this saved process icon, drag it onto the image that I want to apply it to, and PixInsight knows that it needs to apply Graxpert with these saved settings to that image. It'll go off, run Graxpert for us in the background, and modify this image and update it with the new settings. And then again, we'll update the screen transfer function. And remember, we're looking at this now with the channels linked, and so we've gotten rid of most of that noise. The next thing I want to do is do a little bit of star cleanup, and let's focus more on the luminance. There's probably some star aberrations in this data, and I know there is in the dual narrowband. You can see the stars just aren't real great, and that's probably because of the clouds that we're moving in. But we're going to use a tool called Blur Exterminator, and the first time I run it, I'm going to use a saved version of Blur Exterminator that has the correct only checkbox marked. And so that's going to run Blur Exterminator in correct only mode, which means it's only going to work on the stars. It's not going to do any sharpening in general. And so I'll just run that on each one of the images. And it's running now on the L-Enhance. This will take about 30 seconds or so, and then I'll run it on the luminosity frame. And so we'll just pause until that's done. Blur Exterminator is done, and you don't see a lot of difference in the image. If we look at the luminance, let me just undo quickly. Oops. Blur Exterminator is done now, and you don't see much difference in the stars. If I look at it with the undo before and after, you don't see a lot of change. Now we want to run a tool called spectrophotometric color calibration, and again, this takes a little bit of setup. You do need to download a Gaia catalog. And there's actually two Gaia catalogs that are used. There's one that's used for plate solving in general, or creating an astrometric solution. And there's a second one that's used for color. And for color, you need the Gaia DR3/SP that has the spectrophotometric details in it. So that has to be downloaded from the website, and then you need to configure PixInsight so that it knows where to find that Gaia catalog. And I believe you do that through the tools. You just give it the information, and I don't think that's where. This is something that you do once when you install it. Off the top of my head, I'm not sure where that setup is, but there's a lot of instructions online. Once that's configured, you also need to configure the color sensor and the camera. In this case, it was a Sony IMX 411, 455, 461 with a Sony color sensor for red, green, and blue. And with that configured, and again, this is a saved process icon. Once you configure it, then you save it. And then once it's saved, you can simply drag it onto the image where you want to run it. And what PixInsight is doing as it's running this, it's looking at the individual stars, and it knows through the astrometric solution where in the sky this is located and what each one of these stars are. You can then compare those stars to the Gaia database that, among other things, includes information about the composition of the stars, from which it can infer what color the star needs to be correct. And then it finds a white balance that does a good job of matching the true color of each one of those stars. And you'll notice that the image changes, so again you need to update the STF screen preview. But now we'll see we have a very neutral looking natural color image. There's not much color in the stars, but the color that's there is the correct color now. And then we'll just run the same tool on the narrowband image, and it's not technically correct to run it with these settings on a dual narrowband image. I find that it gets me closer to a good result, but in this case, as you'll see as we go through the processing, I'm just trying to get this the dual narrowband data close, not necessarily perfect, because ultimately what I'm after are these red nebula areas that are within this galaxy, and that's what we want to be able to pull out. And it looks like in this case it wasn't able to run calibration on this full file, so we'll just skip it for now. It's having trouble identifying the stars, and again that's probably because of the fuzziness of the stars. So now we're ready to do a second round of Blur Exterminator, and in this case I've got an aggressive version, and what aggressive means is that I've turned up the sharpened stars from 0.25 to 0.35. That's the only change. And then again I saved an instance of these settings, and I can now run Blur Exterminator with the more aggressive settings on each one of these files. And again, this will take about 30 seconds to run on each file, so I'll run it on both files and then we'll continue on. We're done now with Blur Exterminator, so I want to stop here for a minute and just talk a little bit about the process. Let's look at the process outline overall, and I want to point out that there's a lot of places here that you could actually stop and say, well, I've got an image I'm happy with. So we ran WBPP, and that created our master lights. The next thing we did then was open those master lights in PixInsight. First we ran GrAxpert, and what that did is remove any gradients, and more importantly it neutralized the background and gave us a decent color calibration. We ran Blur Exterminator in correct only mode, but in reality once you've run GrAxpert, and if you are happy with the auto stretch either the way it is or with unlinked channels, you could quit there and save that as a 16-bit TIFF or JPEG or whatever you want to work with, and you have a finished image. We're doing a little bit more processing with that. We used Blur Exterminator to in correct only mode to sharpen the stars a little bit. Then we ran photometric color calibration to give us true colors of the stars. Then the last step that we just finished, we ran Blur Exterminator to sharpen the entire image. And Blur Exterminator does a process called deconvolution. It's not really sharpening, it's a little bit different process, but most people call it sharpening. It's really deconvolution. The next thing we're going to do is actually stretch these master lights into a non-linear image that would be viewable just as a normal image. And then we're going to run Noise Exterminator, which cleans up any noise in the image. And again, after that you could save that image and you would have a very usable image. We're going to go a couple steps further because we're going to run Star Exterminator to separate the stars from the background, and then we can process the stars in the background separately. And we're going to do that processing in Photoshop. So the last thing we'll do in PixInsight is save those files as 16-bit TIFFs before we go into Photoshop. So I wanted to just give a brief overview of the overall process flow so that it makes sense from a high level. So let's go back to PixInsight. Now we want to stretch these images, and I do it the easiest way. I use the screen transfer function tool and then also the histogram transformation tool. And the reason you use histogram transformation is because the screen transfer function it doesn't actually stretch the image. It only stretches it for viewing purposes, but it does record the settings that it's using. So we can copy those settings down to the histogram transformation and then apply that to the image to actually stretch the image. So let's start with the color RGB image. We'll update our screen transfer preview. And that's a pretty good stretch just as it is. I mean, we could just use that straight out of the box. I find the background is usually a little too bright, and so I usually like to adjust it a little bit. And to adjust it, if we click on the little plus icon, that will let us zoom in. And as I click, you can see I'm starting to zoom into the settings bar here, and you're starting to see a couple sliders. And if I put that plus sign between the sliders and zoom a little bit more to spread them apart, now I can go back to the arrow tool and I can actually grab the sliders and move them back and forth. And you'll see the one on the left is the darks slider, and we can make that background a little darker. We don't want it to be pure black. In other words, we don't want it to be as dark as this background in the histogram transformation. And then we want to pay attention to the very bright areas and make sure that they aren't going to pure white. And it looks like that's doing okay. There's still detail in all areas. So in order to apply this, we actually have to take the triangle remember that drags out an instance with the settings. What we're going to do is drag that down to the bottom bar of the histogram transformation and then let go of the mouse. And you'll see immediately what used to be a straight line is now a very sharp curve. And when I click the square, it will apply that stretch to the base image and actually stretch the image. Now the image turns white because we're also looking at it through this auto stretch screen transfer function. So we stretched the image and now we're stretching that view again. So that's why everything looks white. And fortunately, we can use this leftmost icon to turn off the screen stretch. And now we see what the image looks like. And if you look at the file name over here, you'll see there's not a green bar. And if we go to one that is still being screen stretched, you'll see there is a green bar. And that green bar is an indicator that this is a auto stretched view. But let's go ahead and stretch this one as well. So we'll update the settings. And then again, we'll darken the background a little bit. And that's probably good. We'll just drag the triangle down to the bottom bar, click the square to apply. This image will turn white and we'll turn off the auto stretch. Now the last thing I'm going to do is I'm going to run two processes on each one of these files. I'm going to run Noise Exterminator and then I'm going to run Star Exterminator. Noise Exterminator cleans up noise in the image, and then Star Exterminator is what actually removes the stars from the image, so it will leave us with a starless image. And the setting that we want to use on Star Exterminator is we want to set this check this box that says Generate Star Image and Unscreen Stars. And what that will do is it'll create the stars image through an unscreen process, which will make more sense when we get into Photoshop. But it will create those two images. So I'm going to run Noise Exterminator and Star Exterminator on each one of these files, and then we'll pick it up from there. We're done now with Noise Exterminator and Star Exterminator, and by running Star Exterminator, it creates new images. So let's look first at the luminance. So here is the luminance image with the stars removed, and then separately there's a separate file, and this is a new file now of the luminance, and this is just the stars that came from that image. So we'll put this back together in Photoshop. Next, this is the stars from the L-Enhance data, and we don't actually need this, so I'm just going to close this file. And lastly, we have the starless version of the L-Enhance, and you'll notice it didn't do a very good job of identifying the stars, and that's because, again, this is not very good data, but what we're really after is just the central part. So we'll, for the most part, we'll be able to ignore that when we get into Photoshop. So the last thing I do here is I will save each one of these, go to File, Save As, and go to the folder where I want to save those final files. And I will save these as a TIFF, and I actually want to save this as a 16-bit TIFF. So in this case it already exists, but what you'll check is 16-bit unsigned integer, and then click OK to save that image. And do that for each one of these three files. And at this point now we're done with what we're going to do in PixInsight, and we're ready to go into Photoshop and put these pieces back together. So let's switch to Photoshop. And I'm just going to close this and we'll start fresh. So to start, first thing we'll do is go to File, Scripts, Load Files into Stack. And what this does is it loads individual files as individual layers within one document. And you'll see why that's important as we go through. But first we have to pick the files to load, and to do that we'll click Browse, and that'll bring up a dialog box where we can again navigate to where we just saved those TIFF files. And the ones we want from here, we need the stars, we need the luminance layer without stars, and the L-Enhance without stars. Click OK, and OK again. And you'll see over on the right hand side it's going to load those three files as individual layers, and you never know for sure what order they're going to be. In this case the stars layer happens to be on top, and that's why that's all we see is the stars. Next, now I can turn off that layer with the eyeball. The layer's still there, it's just turned off. Next is the luminance, or what I'll tend to call the RGB layer. And then last is the L-Enhance data. So let's deal with them just from top to bottom. First, and the stars we do want as the very top layer, so it's in a good spot. If it wasn't, we could just click and drag it to a different spot within the layer stack. I want to put this image within its own layer group, and to do that I'll just select that layer and use the keyboard shortcut Control-G or Command-G on a Mac, and you'll see that created this group which now contains that one layer. I'll double click on the group name and change it to stars. And if you recall, when we created the stars layer, we told Star Exterminator to use the unscreen method. So to put these back, we need to screen the stars back in, and we get to that through a blending mode. And you can see the blending modes is currently in pass-through mode, but if I click on the drop down, it'll reveal a little drop down menu that shows normal, dissolve, lots of different blending modes. And the one we want is screen. And you'll notice when I choose screen, now we can see the stars and we can see the layer that's underneath it. And that's because in screen mode, anything that's black is basically ignored. You could think of it as adding whatever's on this stars layer to whatever's below, and everything that's black is 0. So when you add 0 to any number, you just get that same number. So black actually has no effect, but where the stars are brighter, it adds that to the background. And the advantage of doing it this way is now we can control the stars separately from the background. And let me illustrate that. I'm going to go ahead and close the stars group and then unclick its eyeball to turn it off. And we'll just briefly do the same thing with the luminance layer. We'll Control G, rename the group RGB. And this time I'm going to come down, I'm going to click on the layer, that RGB layer itself that's indented a little bit underneath the layer group name. And I'm going to add an adjustment layer. I like to keep the adjustments panel open, so I can just click on this second icon, which is to add a levels adjustment layer. And when you add an adjustment layer, if you're on a layer, it will add that adjustment layer directly above it. It will change the focus so that that new layer is the one that's currently selected. And if your properties panel is open, we can see the properties for that levels adjustment. Levels adjustment is like the histogram adjustment in PixInsight. We have a set of 5 sliders. And these bottom ones especially can be a little bit confusing. Just very briefly, the top slider, this is the blacks slider, the midpoints, and the whites. If I move the black slider in, it's going to make the darks darker, so it will make that background darker. You can see that as I slide it in. The midpoints would make midtones lighter or darker depending on which way I slide it. And then the whites slider would make the brights brighter. Now, you'll notice if I slide it in, all of a sudden we can see the center here is changing to just pure white. That means we're losing detail. Anything that's pure white doesn't have any detail. So we don't want to do that. And we kind of know we don't want to do it by looking at the histogram. And the histogram is showing that we have data all the way up to almost pure white. Now, the lower sliders, where this slider, when I move it in, makes darks darker, this bottom slider, when I move it in, makes darks lighter, kind of goes the opposite direction. So if I wanted to make my darks lighter, I can't slide this top slider any further to the left, but I can slide this bottom slider to the right, and you'll see that's making the darks lighter, which I don't want to do. I could also use the brights slider to make the brights darker, and we probably don't want to do that on this image. Sometimes you have images where you do want to darken the brights a little bit. So in this image, I'm really just going to darken the darks, but again, I don't want it to be black. I don't want to do that. I want it to be almost black, but still with some detail. And you can see some of that detail is just noise. We'll clean that up later. And then I might want to adjust the midtone a little bit. And let's just say that's a good result. And let's turn the stars back on. And you can see we've now added the stars back in. But notice if I continue to move this midpoint slider, I'm adjusting the brightness of the galaxy without affecting the stars. Now, I can also do the same thing with the stars. If I expand that group, click on the stars layer, and I'm fighting a sneeze here, I'll probably sneeze in a minute, and then add an adjustment layer within this stars group. Now I can adjust the brightness of the stars, and notice that it doesn't affect the galaxy itself. I'm only affecting the stars. So we might want to actually even dim the stars a little bit, which we can do with this midpoint slider. Or we can use, remember the slider at the bottom that makes the whites darker? We could even darken the whites a little bit to tone down the stars and let a little bit more of that color shine through. So it gives you tools to directly adjust the stars independently from adjusting the background. And that's really the power of this starless workflow. Now, the next thing we want to do is address the dual narrowband. So let's turn off the stars and the RGB. And here's our dual narrowband. And this is a little bit different version because it's the version I saved earlier. But you can see we've got these red blotches within the galaxy, and that's what we want to bring out. So what we're going to do is put this first into its own group, and we'll name it LE for L Enhance. And we're going to move this layer group up above the RGB group. And you'll notice if I turn the RGB group on and off, nothing happens. If I come up to the L Enhance, we can do a couple things with this. The first, we can choose to use only the red from this channel because that's where the information is that we really want to add. And an easy way to do that is if you go to the layer group and double click to the right, that will open the layer blending options. And you'll notice in the center, because this is an RGB image, you have each of the three channels, red, green, and blue, listed. And all three are currently selected or enabled or turned on, if you will. If I turn off the green and blue channels, that leaves only the red channel. So right now, this RGB layer, let's go ahead and click OK. This RGB layer is putting out red, green, and blue. You can think of it that way. The layer above it is putting out only red. So the red from this L Enhance layer is replacing the red from the RGB layer, but it's letting the green and blue continue to come through. So if I turn this layer on and off, we're only seeing the red from this layer. And we could go ahead and add a levels adjustment within the L Enhance. And like we did before, we can darken this background and try to find a combination that looks good. But we're getting a lot of weird colors in the center here. And we can probably address that through a process called continuum subtraction. Let me do something else first. I'm going to change the blending mode on the L Enhance from pass-through to screen. Now, rather than just using the green and blue from below, we're applying the red across the image. And that's giving us this red color cast. We can adjust the brightness, but we can kind of make it go away, but it's hard to separate the nebula from the red that's in the center. To clean that up, we're going to use a process called continuum subtraction. And that's a fancy sounding name, but what we're doing is the dual narrowband filter is picking up just a very narrow slice of the red spectrum. But it's also picking up red that's just kind of general red because these stars are putting out all colors. And what we want to do is subtract the general or continuum red from the narrowband to get a more focused view of just the narrowband data. So to do that, we're going to use the RGB image, and we'll just make a copy of it. An easy way to make a copy is Control-J, Command-J on the Mac. And we'll drag this up above our dual narrowband. So if we focus on the L Enhance data, this is our L Enhance image, and right above it is just the RGB. And what we want to do is subtract the RGB image from the L Enhance image. And we'll do that again through a blending mode. And as you might guess, since we want to subtract, we'll choose the subtract blending mode. And you can see that cleaned up that contamination in the bulk of the galaxy, but it also went too far and it got rid of the pieces that we want to retain. So we need to adjust the brightness of the continuum that we're subtracting, and we're going to do that by adding again a levels adjustment layer, and this time we're going to use what's called a clipping mask. We're going to, kind of a bad name, but we're going to clip this adjustment layer to the layer just below it so that it only affects that layer. And we'll do that using this clipping icon that's within the properties panel for the adjustment layer. And you'll notice when I click on that, the levels adjustment inset, and it shows a little arrow pointing down showing us that this levels adjustment is clipped to this layer below it. Now when I adjust this levels adjustment, it's in effect changing the brightness of the RGB layer that we're subtracting from the L-enhance. And it's a little bit trial and error, but typically you need to move the center slider to the right. And you can see that as I move it across, that starts to let the RGB areas come through. And then we may need to move one of the other sliders to reduce the amount of contamination in the center. So in this case, it's this bottom black slider and the top middle slider. And that does a good job of separating the nebula from the background. Now, we've got a lot of just junk going on out here because of this being poor data. It's good enough to show the process. It doesn't really give us a great result. So what I want to do is just hide, everything in this L-enhance. That's where all that red splotchiness is coming from, and I want to just hide all that. So to do that, I'm going to add a layer mask to the L-enhance layer group, and I can add a layer mask by clicking on this what looks like a front-loading washer, black rectangle with a white circle. That will add a layer mask to the layer group, and that's this little white rectangle. Anything on the mask that's black will hide whatever that mask is controlling. So if we grab our brush tool and have 100% opacity and 100% flow, painting with black as our foreground color, any place I paint with black, it's going to hide, and I can make the brush bigger and smaller with the left and right bracket keys. I can just go around here and paint out all of those red splotches because they're not adding any information to the image. If I need to get more precise, I can make the brush smaller and get in here a little bit closer and clean that up so that we don't have that contamination. So now we have a better looking image where we're getting good separation between the nebula and the background, and we also have a second adjustment layer, the second levels adjustment layer within the L-enhance, and this is going to affect the brightness overall. So if I want to brighten those nebulae a little bit more, we can play with the balance here and find just the right balance to keep the visibility of those nebula without them becoming garish and without that red bleeding over into the galaxy overall. Now, I mentioned we've still got some noise in the background. When you turn the star layers on, you don't really notice it because a lot of that noise is related to fuzziness around the stars. So we can actually just quit here. We've actually done quite a bit of work. But if we want to clean up the background, let me show you one last trick. And to do that, I'm going to close the layer groups. And incidentally, you never collapse these. You keep these intact so that if I save the file and I want to come back tomorrow or next week or next month and make other adjustments, I still can. And let me mention also, I'm working against a black canvas in Photoshop. You can change that color through the preferences, but you can also right-click, and you can see that you can choose the default color, which in my case is a medium light gray. You can choose black, or you can choose a custom color, and you can even select the custom color. I've already selected that custom color to be white, so anytime I select custom, I get a white background. If I select default, I get a gray background, and if I select black, obviously I get a black background. And what you want to do is make sure that nothing in the image is as black as the background. So let's add a levels adjustment layer above our L-enhance but below the stars. So this is going to be a global brightness adjustment. It will brighten or darken everything except the stars because it's below the stars. And if I slide the black slider in, I can make the background even darker. You can see eventually it will go to just pure black. And we don't want it to be pure black. We want it to be dark, but not pure black. And we can make it nice and dark so that most of the noise disappears. But when we get it dark enough for that noise to disappear, then some areas get too dark. So what we need is a tool that will keep anything in the image, anywhere in the image, from getting too dark. And generally, too dark is anything below RGB values of about 19. So let's add a solid color adjustment layer. And to get to that, we have to come down to the yin-yang symbol at the bottom. Click on the yin-yang symbol and choose solid color. And what we want to do is add a solid color adjustment where these RGB values are 19, 19, 19. Now, you can just click in each one of these boxes and enter 19, 19, 19 in each one. Or a shortcut, when you first open this dialog box, you can see that what's selected by default is where it says 000 and a pound sign in front of it. These are hexadecimal values. And without getting into the details of what hexadecimal is, let's just remember that 13, 13, 13 in hexadecimal is the same as 19, 19, 19 in regular decimal values. So if I just type 13, 13, 13, 13, 13, 13, I've now set this to 19, 19, 19 as RGB values, and I can click OK. And you can see now that the background is certainly brighter than the black canvas. Stars look good, but we don't see the galaxy through it at all because this is an opaque layer. We want to use this just as a black floor level, if you will. And to do that, we're going to change the blending mode of this layer from normal to lighten. And what lighten is going to do, anything that's darker than 19, 19, 19 will get lifted to that level. Anything that's brighter, this layer will have no effect. Now if we come back to this levels adjustment, if we play with the black slider, we can start to see a point where the noise disappears, but we still have good visibility around the galaxy, and we can play with the midpoint. Something like that. That's gotten rid of most of the noise. There's a little satellite galaxy around M81 right here, and we want to be sure we don't obliterate that. But we have a spot over here where there's some lens flare coming in from a neighboring star, and we want to remove that. And the way we're going to remove that is we're just going to paint it black. And no matter how dark we make it, this layer of 19, 19, 19 is going to keep it from getting too dark. So we'll just add a blank layer here. And I'm going to take my black brush. And in this case, we could just paint with 100% opacity and flow with black right over that lens flare, and it's gone. And the layer we just created looks like this. So what we did here, we just created a big glob of black, and because it's underneath this layer that says no, we can't have anything darker than 19, 19, 19, it raises it up so it blends in with the background. So in this case, we didn't have to be subtle, we could just easily paint that out. Now if we want to darken the glows here, we would have to be a little bit more subtle, and I'll leave that for a different exercise because this is actually just glow around those stars. So just briefly summarizing what we've done here, we imported the three layers. We had an RGB layer, We had a layer that has the L enhance that we did a lot of work to. And then we have the global layers that sets the background, and then we have the stars layer on top. At this point, I would save this as a PSB file. You will go to File, Save As, and you want to choose to save this not as a TIFF but as a large document.psb file. Give it a name, and I always save these in my 2024 folder, which I would have to navigate to, but I think you get the idea. You just save the document like you would save any other document. This is my PSB into my 2024 folder. Click Save. And the advantage of saving it this way is we have all these layers intact. So I can close this layer, I could close Photoshop, I could turn off my computer, come back next week, go to File, Open, and reopen that image, and there's all the layers intact. Here is our levels adjustment layers. So if we want to come back and adjust it again, we can. Nothing is ever really finalized until we decide that we're actually done. And when you do decide you're done with it, you don't flatten this image. What you do is you would do a save as and save it as a JPEG or a TIFF or something as a derivative version of this, so that you always have your master file to come back to. My personal workflow, I would go to Lightroom and import this PSB file into Lightroom, and then do my final tweaks and edits and cropping in Lightroom. So that's the overall workflow, getting from the raw data to a finished image in Photoshop. I know this is kind of a long tutorial. I apologize for that, but I think sometimes it's better to just take the time and go through all the steps so that it's there for everyone to see. If you have any questions, drop them in the comments down below. And with that, I hope you have a great day today and an even better night tonight under a clear, dark sky. Thanks.